geometric series, the sum to infinity. This room is 8 meters wide, and somebody starts on the left and they're going to walk towards the right, but they only ever walk half the distance between themselves and the wall on the opposite side. So initially they walk 4 meters. Now the distance between this person and the opposite wall is 4 meters, so they're going to walk half of that distance again, which will be 2 meters. So far they've walked 6 meters. And now the distance between this person and the wall is 2 meters. They will walk half of that, which is 1 meter. And you can see the pattern. It's just halving each time, so then it will be half a meter plus a quarter plus an eighth, and so on. So if you ever walk half the distance between yourself and a wall, do you ever reach the wall on the opposite side? Or do you just get closer and closer and closer to it, but never quite reaching it? And you can do this an infinite number of times, so you have an infinite number of terms, and we can work out the sum of an infinite number of terms, and we can see that it will approach the original width of the room, which was 8 meters. So this is the sum of an infinite geometric series. So in the formula for the sum of n terms, n approaches infinity for an infinite number of terms. So what will the sum of an infinite number of terms give us? So what does a half to the power of n, where n approaches a very large number, infinity, what does that give us? If you try this on your calculator and then increase the value of n, and n is even bigger, so what will this be? And what you'll find is that it approaches 0. So if this is 0, we can simplify, simplifying further, so the sum of an infinite number of terms in our sequence here for the room approaches 8 meters, which was the width of the room. Now this only works if the value of r is between -1 and 1. So the value of r needs to be greater than -1 or less than 1. An alternative notation for this is like this. So you've got r, you've got these two vertical lines on each side. It means the magnitude or the size of a number. It has to be less than 1. If r is outside this range, then the sum to infinity will be infinity. The formula for the sum of an infinite number of terms is this, and the series is said to be convergent. Just like this series, this geometric series, which converges to the width of the room, which was 8 meters. Example 1. The 4th term and the 7th term of a geometric series are given. So using the nth term formula, we can write these. N is 4, n is 7, n is 4, and n is 7. Simultaneous equations. Divide the equations, cube root, and we see that r is between -1 and +1, so the series will be convergent, and we can work out the sum of an infinite number of terms. and we can solve to work out the value of a from our simultaneous equations. So to work out the sum to infinity, we use our formula, substitute the values in, 12.5. So the sum of the series converges to 12.5. For this series to be convergent, and to find out the range of values of x to make the series convergent, we work out r, so we just take any two consecutive values. So we have this value here and the one before it. It's the one on the right divided by the one on the left. So r is equal to minus 2x. And we know that r should be between minus 1 and plus 1 if the series is to be convergent. And we know r is minus 2x divided by minus 2. And if we rewrite this in our standard form, like this, we can show that x is between minus a half and plus a half, or alternatively we can use this notation, that the magnitude of x is less than a half, and the sum to infinity, we just substitute the values in, 1 over 2x plus 1. And r was minus 2x. Just be careful with the signs here. Use brackets around the minus 2x. For practice, have a go at this exercise, question 3 onwards.